The next presentation we have is a tag team. I don't know if you guys are familiar with wrestling, Caribbean wrestling. We used to have Invader number 1 and Invader number 2. Invader number 1 in this case is architect Robert Woodstock, who's a Jamaican architect with over 45 years practicing in the Caribbean on many projects in many different islands. He has been the recipient of many awards. I would encourage you to read the bios again for those details. And Invader number 2 is Tony Gibbs, who has been introduced a few times already. Who's coming first? Oh, so you're Invader number 1. Okay.
Oh, designing for earthquakes. Right. Is Robert Woodstock on my left? Some years ago, I asked Robert to give a talk on designing for hurricanes. He said, Tony, I don't hear about that. So I said, well, could you give me a name of a Jamaican architect we could ask? He said, they don't know anything about that. I said, but you just had Hurricane Gilbert in Jamaica, so you know all about it. Anyway, so I said, I invited Robert to my office in Barbados, and I gave him some books to study, and he made a very good presentation on how to design for hurricanes. So he knows a lot about that. So buildings are designed by architects and engineers. In reality, in most cases, buildings principally for human occupancy are designed conceptually by architects. That is to say that architects are the ones principally responsible for the configuration of buildings for human occupancy. They're the ones that make those decisions. Configuration has to do with the shape and size of the building. Inevitably, shape and size has, to a large extent, determines or greatly influences the type, shape, arrangement, size, location, and most other aspects of the structural concept. In the words of Geoffrey Wood, one of the 5 founding partners of O'Varappan Partners, earthquake-resistant design is really a problem for architects. So several years ago, the Institution of Structural Engineers Caribbean Regional Group, with support from the Pan American Health Organization, Dr. Van Alphen, hired Luigi Desano to deliver a series of 3 programs, 3 lecture series. There were 3-day courses held in Jamaica, Barbados, and Trinidad. The first day of those courses, the courses were in base isolation. The first day of those courses was devoted to architecture. So we invited the Barbados Institute of Architects, the Trinidad and Tobago Institute of Architects, and the equivalent body in Jamaica to attend those courses. Not one single architect attended any of the courses in Jamaica, Barbados, or Trinidad. But Geoffrey Wood said, earthquake-resistant design is really a problem for architects. So either the architect has a better than usual knowledge of the basic principles of the conceptual design of earthquake-resistant systems, or the architect should involve the structural engineer in the initial discussions and development of the building concept. That's the central bank in Barbados. It's not a correct representation because our Prime Minister, Tom Adams, at the time, thought the building was too short. So after the model was built, he told the architect, add 2 floors. So the actual building is 2 floors taller than that. But before Mervyn Awan, the architect, drew a line, Mervyn and I spoke about the building for 2 weeks. And in those 2 weeks, Mervyn conceptualized the building in such a way that it made my life a lot easier to designing the structure. And the extra overcost of earthquake-resistant design of the structure, or extra overcost over simple gravity loads, was $0. Now, the Tri-Services Manual of the USA Army, Navy, and Air Force states, a great deal of a building's inherent resistance to lateral forces is determined by its basic plan layout. Engineers are learning that a building's shape, symmetry, and its general layout developed at the conceptual design stage are more important than the accurate determination of the code-described forces. There's a well-known structural engineer, William Holmes, writing in 1976, he stated that it has long been acknowledged that the configuration and the simplicity and directness of the seismic resistance system of a structure is just as important as the actual lateral design forces. Another famous engineer, Henry Degenkolb, who was lectured in Trinidad in 1978, he was here for a major conference at the Hilton. Degenkolb is emphatic in stressing the importance of configuration. He says, if we have a poor configuration to start with, all the engineer can do is to improve a basically poor solution as best he can. Conversely, if we start off with a good configuration and a reasonable framing scheme, even a poor engineer can't harm its ultimate performance too much. So if you have poor engineers, make sure you have a good configuration. And this last statement is only slightly exaggerated. So, what I have said so far warrants discussion among the various disciplines involved in the design and building processes. A Nicaraguan architect called Terran, he recommends that buildings be simple, continuous, symmetrical, straightforward, and repetitive. And this advice is given not as an absolute, but as a qualitative factor that influences the reliability of the structure. Terran, the architect, asks for understanding and knowledge among the disciplines, not the imposition of mandatory constraints. Those 2 slides and several others come from a very good package of slides from the Pan American Health Organization. It's the health sector that's interested in safe buildings. Not the Ministry of Works, the Ministry of Health Very interesting. Now, that's a hotel at Heathrow Airport in London. That's a perfect shape for earthquakes. That hotel in the bottom is a circular hotel with shear walls around the perimeter, in a perfect location for resisting torsional forces. It's symmetrical. I don't think the engineer and the architect at Heathrow Airport were concerned about earthquakes, but accidentally they produced a perfect earthquake-resistant design for the aerial hotel at Heathrow. I think Luigi spoke about soft stories at the Olive View Hospital in San Francisco. You know, that earthquake in 1971, the San Francisco earthquake, San Fernando earthquake, 1971, over 90% of the deaths occurred in hospitals. And that's interesting. And Olive View was rebuilt after that 1971 earthquake. And it was rebuilt to the best standards available in 1971. And in 1993, when the Northridge earthquake occurred, Olive View Hospital was closed for a month to patients. So even the best standards are insufficient if you don't have base isolation. Because earthquake resistance depends on the failure of elements to absorb the energy. Yeah, soft stories kill people. Killed 18,000 people in the Izmit earthquake in Turkey in 1999. So what we need are weak beams for earthquake resistance. We need our beams to be weak so the columns don't fail. If you have strong columns and weak beams, you're in better shape than if you have strong beams and weak columns. Of course, most of a building is non-structural. Most of this building is non-structural. So we should really pay attention to the non-structural components as well. And that's outside of the realm of engineers. This particular building, let's go back. This particular building is interesting because it has a 200 millimeter separation joint from the top to the bottom. It's of the 15-story building. That's for earthquakes. So that one side of the building does not clash against the other side during an earthquake. But the corridor between the bedrooms and both sides of the building has a ceiling like this, which runs continuously across that joint. And when there have been four earthquake events in the 50-year history of this building, it was opened in 1974. The first event, the ceilings broke, and if at every floor, every one of the 10 bedroom floors, you saw this gash in the corridor, which alarmed the management, and they called our office in Trinidad and said, come and see what's happening. The building is falling apart, breaking in half. So we came, our report explained to them that there's a big joint there, but the architect had put a continuous ceiling across it. So it's just a ceiling to be repaired. The next event, the second event, was a different manager who didn't know what happened under the previous manager. So the same thing happened. He called the office. He's alarmed. We came and we got out our old report and changed the date and collected a new fee. It happened another time, a third time. A new manager, no institutional memory. And we collected the report, changed the date, sent a new fee, and collected the fee the third time. But the message never got through that the ceiling should not ignore the joint. The ceiling should recognize that there's a joint there. The fourth time it happened, they figured it out. And they didn't call us. We were very upset. And Shalini actually sent me a photograph of the corridor for that fourth event. But I don't have the photograph in this package. So if you have joints in the building, then the architecture detailing has to recognize the joints. Or otherwise, the consulting engineer is going to get wealthy out of the reports. And if you have an irregular building, then you go to Luigi and you get it base isolated. Or Shalini is doing that these days. So that's a solution for those who want irregular buildings. But by having base isolation, you avoid the excitement of being in a non-base isolated building. So, which one would you prefer to be in? You want the excitement, or you want to be in have a dull life? You see. So there are other ways of dealing with this. You could have energy dissipation with mechanical devices. I think I can show you some of those mechanical devices if I get this thing to work. The thing is to absorb the energy. And after the Mexico City earthquake in 1985, the following year I went to Mexico City for a one-year commemorative conference. And in the Social Security building, I saw that yellow thing there. I can't see it. I can't see over there. There's a yellow device there, similar to what Luigi showed, to absorb the energy of the earthquake. That's a retrofit method. Okay, that's really all I'm going to say, but my co-author, he will examine the problems for the architectural designer when confronted by earthquake hazard and some of the possible solutions to these problems. You know, the past 30 years, there's been inadequate attention to the earthquake hazard by the engineering community and almost none by the architectural profession. It is hoped that in the next 30 years, we will see all disciplines among design professionals paying much greater attention to earthquakes and much more collaborative design at the early stages of projects. Thank you.